now I'm going to basically introduce to you climate change and try to focus with you on what together we can do. And instead of just talking, I was mentioning something to a young lady there at the table with me. And she says, you know, we talk and talk and talk. When will we start to walk? So let's walk the talk. Next. So I'm going to basically give a brief, this is the structure of the presentation, a bit on paleontology and climatic forecasting, look at the results of the Intergovernmental Panel on Climate Change. I'm sure you've heard about that, the IPCC. Look at the work that Nicholas Stern of Britain has done on the economics of climate change. Look at the consequences or the impacts of climate change and have a discussion with you on what we can really do to make our contribution. So, paleoclimatology in a nutshell, if you look at the tree ring there, it's from a tree, and you can see all the rings. And where are we able to forecast past temperatures and rainfall from? We look at the flora and fauna in each ring of that tree. And you can see it if you cut a tree as well. And it gives you an idea of what existed at that time. And you know that apples don't grow here. So you can have a very good example of what was grown at that time, what the temperature would have been. The animals that survive as well. You don't get polar bears here. So if you see there remnants of a polar bear, you know it will be a colder period. So that each ring will tell you what the temperature and what the environmental conditions would have been at that time. Also, you can do the same thing from a glacial ice core. When you drill down into the glacier, take out a core of it and look at the different levels in it. So this is where scientists are getting the evidence of what past climates were like. Quickly, and I don't have a pointer, so just follow with me. These are some of the eras, historical eras. If you notice the temperature constantly rising over time. And if you look at the first peak, glaciers retreat and sea level rises, you can see every time a glacier retreats, the sea level goes up. And it's something that is happening right now in the Arctic. Just follow the colors here with me. The blue on the top, a bit dim, would be our glacial cover in the past world. The present world below, you notice it's no longer blue, it's green. The glaciers are retreating, as one of the young ladies just said. Forest cover is increasing there, which is a good thing for climate change. Through the years, we're seeing here temperatures rising, but if you look on the right of the screen, there's a line that says 2 times CO2, where carbon dioxide levels are now doubling. And the dashed line going up, showing you that basically, lovely. How do I do this? This one. Great. Thank you. So if you look here, carbon dioxide doubling, future decades, and the dotted line, the dashed line, is showing you that temperatures are expected to increase as carbon dioxide levels increase. So this Intergovernmental Panel on Climate Change, have you heard about it? How many people here have heard about the IPCC? Right, some people have heard. Okay, it is a body that has met and they produce a report. And they're now working on what we call the AR5, the assessment report, the 5th assessment report. So we are working with the AR4, but the 5 is being prepared at the moment, where they are constantly reviewing increases in temperature, changes in precipitation, changes in sea levels as well. So these would be results of the AR4. So what is the IPCC saying? The IPCC is saying that global concentrations of carbon dioxide, methane, and nitrous oxide have increased since 1750. And the point that we were trying to get out of the second question is as a result of human activity or anthropogenic activity. So we are the culprits, right? We are doing it. We are causing it. So we are responsible. Second finding of the IPCC, CO2 increases are due to fossil fuel use and land use changes. And I commend the sponsors of this event. When I look there, and I see oil and gas and Methanex. Another finding, methane and nitrous oxide increases are primarily due to agriculture, and the increase in CO2 from 280 parts per million to 379 occurred in 2005. Currently, and I got this data from yesterday, it's now 395.77. So it's going up. Continuing with the main findings of the IPCC, warming of the climate is unequivocal. It is happening, it's a reality. We no longer need to debate that. We need to work with it, accept it and work with it. Increases in global average air and ocean temperatures are occurring, and there is widespread melting of snow and ice. Rising of global average sea level from 1.8 millimeters per year between 1961 and 2003. The rate of sea level rise was faster between 1993 and 2003, and changes in Arctic ice and temperatures rising and the ice melting. Changes in precipitation, we can't say going up or down because some places are flooding, others are drying out. So there are changes in precipitation. Changes in ocean salinity, which will affect our coral reefs from ocean acidification. Changes in wind patterns in extreme weather events, including droughts and heat waves, and changes in sea surface temperatures. Changes in tropical hurricane activity in the North Atlantic have been observed since 1970, and these correlate with increases in sea surface temperatures. So what are the IPCC projections for us? For the next 2 decades, we are going to see a warming of about 0.2 degrees centigrade per decade. And they are saying that even if concentrations of greenhouse gases and aerosols are kept constant at 2000 levels, a further warming of about 0.1 degrees Celsius is expected, and this would cause additional warming. Just to trace the emissions of CO2, with time 1850 to 2000, we see land use in green here, conversion of agriculture to different forms of land use, and look at the emissions of greenhouse gases going up to 2000, and a steep increase from 1950 to 2000. Coming on to the Caribbean now, the temperature trends, and you can look at the graphs, Barbados, Trinidad, St. Lucia and Dominica. Look at the line going up. It's an upward line in all of the countries. So temperatures are indeed increasing, and rainfall patterns are also changing. Caribbean Sea is much warmer than it was. You look at the scale here, and you will see a lot of red going on here. The April sea temperature here is about 27 degrees Celsius. We're seeing also the development of stronger hurricanes at lower latitudes. We had Tropical Storm Ernesto passing through the region, not doing any great damage, but really coming a bit lower south. There's evidence that the intensity of these storms or hurricanes is increasing, but we're still debating whether or not the frequency is increasing. We also see a more rapid transition to Category 4 and 5 hurricanes, and increases in sea temperature would increase the likelihood of coral bleaching. This has come from the Institute of Meteorology in Cuba, INSMET. And INSMET is saying, if you look at the index there, greater warming over land areas than over sea areas. So this will be less warming, greater warming as you move up the scale. So we're going to have greater warming. Cuba, Hispaniola, all the land masses are going to be hotter than the sea areas. And what is it going to do to our coral reefs? Tobago, we think about Tobago here. What is it going to do? In 1998, coral reefs around the world suffered bleaching, And I know many of you, I was talking with some of you earlier, you're students of biology, and you know about the symbiotic relationships between the corals and the little green organisms that live in them. And when the temperatures rise, they expel these green organisms upon which they depend for their livelihood, and they die. So that's what's called coral bleaching. So they become white, they're bleached. So we're seeing too, when this occurred in 98, coincidentally, the same year, tropical sea surface temperatures were the highest in modern record, topping off a 50-year trend for some tropical oceans. And the repercussions and the mortality that occurred will continue to be far-reaching in time and space, especially when you take into account that a single bit of coral grows 1 centimeter in 20 years. How can we replace Bucco Reef? Further examples of what's the impacts of global warming. Yellowfin tuna, called yellowfin because you see the yellowfin there. Look at its distribution here. The red showing you where they are distributed. With a 1 degree rise in temperature, the red disappears from the Caribbean region. So our fishery resources are being impacted. Parrotfish grow on the reefs, and you may have seen some of them in live parts of Bucco Reef. Same thing, you see the red here? Disappearing from our island shores here. And last one, the dolphin fish, you call it mahi-mahi, dorado, different names. Again, this is the current distribution of it. With a 1 degree rise in temperature, they fail to exist here. So, Stern, you would have heard of Nicholas Stern, who did the first set of work on the economics of climate change. And he attempted to say, we're always saying that climate change is occurring, temperature patterns are increasing, precipitation patterns are changing, sea levels are rising, but what is it going to cost us? And we know that policymakers understand dollars and cents. And he attempted to do the first analysis of this for Britain. What is it going to cost us if temperatures rise, if we have different changes in climate? And he is saying, it is going to if we don't act, it is going to cost, we're going to lose at least 5% of our gross domestic product. This could rise to 20% if a wider range of indirect impacts are taken into consideration. And our actions now and over the coming decades could create risks of a disruption to economic and social activity on a scale similar, I'm sure you've heard about the Great Depression, on a scale similar to the destruction wrought then. It will be difficult to reverse these changes. The costs of stabilizing the climate are significant. It's going to cost us, but they are manageable in the long run. And also, delay would be dangerous and much more costly. So I'm asking you, what can we do today? And you can give me your ideas as we go along. The cost, if we want to reduce our greenhouse gas emissions, it's going to amount to just about 1% of our GDP, according to what Stern has said. The investment that takes place in the next 10 to 20 years would have a profound effect on the climate in the second half of this century and the next. In other words, we are thinking sustainably. We are thinking of future generations and what kind of world will we live for them. The response must be international. We can do a bit here, and I'm sure many, many of you have heard that even though in the Caribbean we contribute to less than 1% of greenhouse gas emissions, we will be the first to be impacted by the changes in climate caused by those emissions. So we contribute less, but we are going to suffer the most. So it has to be an international response. We can do what we want here, but those who emit the most are the ones that have to take concerted action.